Okay, so hello everybody. Welcome to another Science Lunch Talk. This week is going to be a little different. Rather than being directly astronomy related, I will actually be talking to you all about recycling practices. So I greatly appreciate everyone here for showing up and listening in. And without further ado, I will get started. Okay. So, hi everybody. My name is Jessie Bublitz. I am a postdoc here at the Green Bank Observatory. Let's see. I'll need to be keeping track of all of the people that are showing up and making sure everyone gets admitted. But in the meantime, so I am a postdoc here at GBO, and I am also a member of the Sustainability Working Group, which was created just this past fall among GBO staff in order to look at the environmental practices of the site and to try and make a broader impact on our sustainability endeavors. So today's talk is actually going to be focusing on recycling and specifically what good practices there are for recycling, what are some common misconceptions, and how you can bring a lot of these practices into your own life. So in this talk, I'll give a general overview of recycling processes for plastics, glass, metal, and how they go through the system, as well as giving you some practical solutions for your everyday life. So first up is plastics, one of the most common and difficult questions when it comes to recycling. So first and foremost, not all plastics are recyclable. Those plastic resin identification codes that are so common on plastic products, which you can see on the right, a little number encircled by 3 tracing arrows in a triangle shape, or more commonly just a solid triangle as of the past couple of years. Now, these resin identification codes are not actually associated with recycling. They were first created in 1988 by the Society of the Plastics Industry as a way of simply identifying different types of plastics. In fact, their official statement is that they are not recycle codes, and they do not imply that an article is recycled or that there are systems in place to effectively process that article. In fact, recyclable, according to them, shall not be placed in proximity to the code whatsoever. And so the more cynical among us would be inclined to say that these codes were actually put in place by the plastics industry as a way of appeasing people who were afraid of all of the plastic being created and thrown away, as a way of assuming that things can be recycled without actually putting any effort into the recycling process. Nevertheless, recycling has sprung up and is actually quite common, particularly for plastics. That being said, there's still a very common process known as wish cycling, in which consumers simply assume or hope that a certain plastic product, particularly ones with different RIC numbers on them, can be recycled and thus throw them into their recycling bins, regardless of whether or not they can actually be processed and recycled. Unfortunately, this slows down the sorting process and drives up recycling costs, with a risk even of contamination, where the types of plastic cannot be easily separated, and you have an entire block of recycled materials, which doesn't meet sufficient standards. So it ends up just getting sent to a landfill or incinerated. Not to mention all of the plastics that are simply left by the wayside in the environment itself. Now, in a study done in 2017 on the production, use, and fate of all plastics ever made, a survey found that approximately 6,300 megatons of plastic waste have been produced since their inception in the 1950s, only of which 9% has actually been recycled. The other percentages consist of plastics that are incinerated, accumulated in landfills, or simply left in the environment itself. Now, another way of visualizing this is with the cartoon on the left, which gives you sort of a visual representation of those sizes with arrows, showing how plastics are produced, brought into primary use among houseware, and are then separated out into materials that are discarded, either in landfills or in the environment, incinerated, or the small number of plastics which have been recycled. And you can see that that then moves into a smaller category of secondary use plastics, having been recycled, that again filter through this system of either landfills, incineration, or smaller and smaller recycling. Meanwhile, you can also visualize this on the right with this figure showing the exponential growth in plastic waste as compared to the fate of that plastic material. So we're over here just past 2020, in which materials production is rapidly expected to increase. And while you will note that this red line, which represents discarded plastics, does seem to decrease in its growth, that does not mean that we are actually appropriately dealing with our plastic waste, as we still have far decreased recycling procedures that don't account for this exponential growth of plastic products. Now, in order to better understand all of the plastic recycling system, we should look at those RIC recycling numbers. Well, rather not recycling numbers, but can be used for recycling. And what they're used in and what their significance is. So first up, we have polyethylene terephthalate, or PET1. This actually makes up less than 10% of the plastic produced. However, it is one of the most commonly seen in our everyday lives. It's strong, it's light, and it's generally transparent, and used in things like bottles, jars, and other types of food packaging. This plastic is rather easily recycled into things like carpet and furniture fibers, as well as new bottles. However, it is not safe over long periods of time with heat. So if you do have, say, a plastic bottle of water that you keep in your car in case you ever need it, constant exposure to heat, especially right now in the summertime, can actually cause antimony in the plastic to leach out into the liquids. So for long-term and heating processes, these plastics are not terribly liquid safe. So that's something to keep in mind, as there are good alternatives to that everyday plastic bottle. Next is high density polyethylene, or HDPE2. This is actually the most commonly produced plastic at 36% of all plastics made. It is far stronger and holds up better in extreme temperatures to PET1. It's typically opaque and found quite commonly in things like milk jugs, cleaning products, toiletries, as well as things like toys and pots and even some pipes. This plastic can then be reasonably well recycled into things like pens, lumber for fencing or picnic tables, and even newer bottles. Next is polyvinyl chloride, or PVC3. Now, you might be familiar with PVC in terms of its plumbing. This is a fairly rigid plastic that can be made flexible with plasticizers. However, its most significant property is that it is non-conductive. For this reason, it is used in everything from credit cards and food wrap, other takeout food containers, as well as plumbing pipes, tiles, windows, but also in many plastic pieces of medical equipment like IV bags. While it is not as commonly recycled and is okay in the short term, unfortunately, it is known to leach hazardous chemicals over long periods of time. For this reason, it is not considered food safe for prolonged periods, and it does require specialized programs in order to recycle it, most commonly into things like flooring, paneling, and apparently even roadside gutters. Next is low density polyethylene, or LDPE number 4. This is actually an incredibly clean and safe plastic. It's easy to make, but it's difficult to recycle. You'll find this in everything from plastic wrap, sandwich bags, bread packaging, bubble wrap, the bags that you'll get at the grocery store, as well as some cups. And while it is not as commonly recycled, several programs have been popping up. You'll in particular find a lot of return policies for like plastic bags or bread bags in grocery stores now. And these plastics can then be converted into things like garbage cans, furniture and flooring, as well as remade into bubble wrap and other plastic bags. Then we have polypropylene 5. This is the second most commonly produced plastic, and you'll find it quite often in your daily life. It's a very hardy plastic that can withstand high temperatures and is considered quite safe for food products. This is why you'll find that Tupperware is made out of polypropylene, bottle caps, car parts, thermal vests, and lots of the containers for food products in your fridge that are meant to last more long term. This plastic can then be occasionally recycled into things like ice scrapers and rakes and things like that, because it is a much sturdier plastic. Next is polystyrene 6, or as you might commonly know it, styrofoam. And while it is not as commonly produced, especially anymore, it is still really cheap and easy to make. And it has a bonus property of being rather insulating. For these reasons, you will sometimes find, and you definitely used to find, styrofoam takeout containers, cups and plates. You'll also find it in insulation and packaging material. Egg cartons still frequently are made out of styrofoam. Unfortunately, this is yet another fairly unsafe plastic that over time and when heated can leach harmful toxins such as styrene, which is actually a neurotoxin, yay, into your food. For this reason, it is not easily recyclable, but there's some systems out there that will take it in order to make new insulation, even things like school supplies and license plate framing. However, this is why styrofoam has become less common and is generally not recommended for, reheating your leftovers or something like that. It's also, very much a dangerous chemical plastic to have out in the environment, in landfills, as over time, those chemicals will leach out into the environment. And the last number, 7, is simply there as a catch-all for any plastic that doesn't fit into the previous 6 categories. You'll find that things like sunglasses, computer casings, CDs and DVDs and Blu-rays, nylon, baby bottles, and other drinking bottles will be made out of these other plastics. Unfortunately, they quite often contain a chemical known as bisphenol A or BPA, which is not suitable for long-term food relation. That being said, there are several plastics in this other category that are actually food safe. In particular, there are Nalgene bottles, which I'm sure many of you are familiar with, which most notably state on the bottle that they are BPA free. For this reason, they are actually safe to keep your water in. You can store them in your car, and even with heating, they won't leach any toxic chemicals into your water, your beverage. Now, in general, the most easily and commonly recycled plastics are the 1 and 2. And honestly, the good way of remembering your plastic recycling is that the lower the number, the easier it is to recycle, most generally. And some things that you should keep in mind when recycling your plastics, particularly 1 and 2 bottles, include the caps and the labels. A big question that people tend to have is, do you leave these things on, or should you take them off before sorting them and recycling them? And while the answer used to be yes, remove them, nowadays, actually, you should absolutely leave everything on. Remove any excess liquid, rinse them out if necessary, but then put the cap back on, and don't flatten the bottles before you put them in your recycling containers. This is because systems for recycling and filtering have actually drastically improved, and you can, they actually will cut up the plastic bottles into tiny pieces, and then using a water bath, they can separate the plastic of the bottle from the separate type of plastic from the caps. And by removing those bottle caps, not only are you either throwing them out, thus recycling less plastic, or if you also put them in the recycling bins, you run the risk that they are going to simply fall through the cracks, literally, as they're so small. So keeping them on ensures that they will be recycled. And similarly, don't flatten your bottles, as in the sorting process, apparently flattened bottles are often mistaken for paper materials, since they don't have that easily distinguishable 3D shape, which is used in the sorting process, and you run the risk of contaminating recycling. Now, when it comes to recycling your plastics, I've talked a little bit about mixing or separating out your plastics, and these fall into the categories of single stream or multi-stream. And it very much depends what your local system, services are available to you. In a lot of cases, single stream sorting is available now, as the machinery itself in the factories is able to handle that sorting. However, oftentimes there will still be a minimum level of sorting and cleaning performed. So always be sure to check what your facility, what your local area's streaming system is, to reduce the risk of materials being thrown out. Also, as I mentioned before, with wish cycling, don't mix in things like plastic bags or packaging wrapping, which can't necessarily be handled even by these single stream systems, as they risk clogging the machinery. There are often other services available for taking those plastics in to be recycled. Also, while single stream recycling is very convenient, and it actually has been found to increase people's interest and ability to recycle, as it requires less work on their end. It also requires less work on the end of recycling facilities for fewer trucks to pick up materials. That means less gas spent on collecting and transporting that material. However, as I mentioned, there is an increased risk of contamination and thus fewer materials actually making it through the recycling process. Things like electronics and batteries, plastic grocery bags, packaging that is plastic on the outside, but maybe contains paper or metal on the inside, or is coated in food and grease and cleaning fluids, will contribute to this contamination. Apparently, the tape, glue, and ink from Amazon boxes have also been found to contaminate recycling, at least when thrown in with other single stream products. So all of this has actually found that while you do get more recycling done, at least in terms of collection, you do actually have a reduced output of the recycling process and a higher contamination. So this can be shown in this admittedly old survey performed in St. Paul, Minnesota, which compared multi-stream with dual stream, which separates paper products from plastics, and then single stream, looking at both biweekly and weekly. And while generally the single and dual stream weekly processing had much higher collection rates, the actual recycled materials tended to be much more contaminated. So as I mentioned, a lot of stores, like grocery stores, are offering various types of recycling, usually right inside their front doors for their shopping bags, as well as various types of packaging for their products. In this case, the grocery store Kroger has teamed up with a group called TerraCycle, which will let you, free of charge, collect all of your plastic food packaging from their brand products, put them in a box. You can print out a label and ship it directly to TerraCycle to be processed. So while it's not always obvious, there are often these systems available. All right, moving quickly into the next process, glass. Unlike plastic, glass is actually infinitely recyclable. Despite this, studies found that only about a third of all of the glass food and beverage containers actually were recycled in the US. In comparison, a lot of European countries have rates of upwards to 90%. And so you might ask, why is this why are there so extreme differences between the US and Europe? Well, there are a couple different reasons. One is the quality of the glass. For us, our more common single stream systems have a greater issue sorting broken glass, which can not only slip through the cracks, but can also make its way into non-glass sorted materials, which can cause hazardous scenarios and contamination. Another component of this is the fact that unlike Europe, we don't tend to have many explicit glass recycling facilities. Over in Europe, for those who've been around, we'll find that across cities, there are actually specific glass bottle or just general glassware bins or containers spread throughout the city. So you just have to go down their block and there's a collection site, just like a public trash can for all of your wine bottles and beer bottles and the like. Next is economics. Glass is unfortunately heavy and expensive to transport. This becomes an issue in the US, which just has such a greater surface area in which to deal with transporting all of these products. So unless the US has the same number of glass recycling facilities per land area, it means you have to worry about transporting all of this glassware much further. And next is availability of the materials. Cullet can vary in specification needs across different manufacturers. And what you may ask is cullet. It is basically the crushed bottles and jars that are produced after being sorted to make it back into the recycling process. So glassware is generally made of sand, sodium carbonate, and limestone. However, you can actually add in a bunch of this crushed glass to the production process to actually significantly improve the quality of the glass that's made. Melting cullet, unlike raw ingredients, does not release carbon dioxide or other gases into the environment. So you actually have a 5% decrease in CO2 emissions for every 10% of cullet added into the glassmaking process. This also means that you aren't going to get as many bubbles trapped into the molten glass as you're making it. You'll get fewer streaks or imperfections as a result of poor mixing of the materials, as cullet is already mixed and processed glass. And you don't run the risk of having some unmixed materials depositing crystals or something of the like when you're creating the glassware. It's also found that 1 kilogram of cullet can replace 1.2 kilograms of the raw material. So that means not only are you replacing the use of raw materials with already processed glass, but you're actually reducing the amount of waste materials in the production process. Now, in order to try and bump up those numbers, there have been many local legislation moves called bottle bills, which have attempted to incentivize people to recycle their glassware. This is something you might have experienced quite often, in which there will be a 5 or 10 cent tax on any glass products that you buy in the store, incentivizing you to then bring those bottles in to get those deposits back. And in places where they have tested these laws, they've actually found a significant increase in the number of bottles recycled. That said, we can actually see that the 33% recycling rate in the US actually varies by the means of recycling. For multi-stream collection systems, there is actually a relatively high 90% of glass that makes it into the systems does actually get recycled. In comparison, single stream tends to only have a 40% recycling rate, again, mostly due to contamination. The other big issue being those bottles that are just left on the waysides of roads and scattered in nature itself. And one final thing to note about glass recycling is things like drinking glasses and plates, personalized glass objects, window glass is a different type of glass than your common bottles and jars and cannot be thrown into the bin with those other glass recyclables. They have different properties, and thus they need to, when available, be recycled in different ways. However, because those systems are not as built up as your common glassware, your common glass bottle recycling, it is generally recommended that you throw away that material. And when it comes to glassware, ideally put them in a container that will keep them safe, and then throw them into the trash. All right, and thirdly, metals. This ranges from common metals like steel, iron, aluminum, to more specialties like copper and lead and tin, to the rare elements like gold and silver and palladium. Now, again, much like glassware, metals are infinitely recyclable. You can reuse them without degradation. It simply requires you to actually get them into the recycling process. Ferrous metals like iron and steel are really easily sorted thanks to their magnetic properties. However, in single stream systems, there are also electromagnetic means of separating out other non-ferrous metals like aluminum. Once they've been bulk sorted, the metal scrap is then shredded, melted, which is admittedly an energy intensive process, and then through steps like electrolysis, purified and cleaned before finally being cooled into materials that can then be shipped out. It was recently found that the most recycled container in the world is actually the aluminum can at about 64%. And in fact, almost 70% of the crude steel that is used in the United States is the result of recycled steel products. So when it comes to individual metals, there are actually some really good results in terms of the recycling process. However, as a whole, only, again, about a third of the metals in the US, so that's about 8 million tons, actually make it into recycling facilities. One of the big problems with that in recent years is the complexity of the materials that contain these metals, in particular electronics, which means that you need specialized methods for extraction. When it comes to things like alkali batteries that have been used up, while they are generally considered non-hazardous, with the sole exception of the state of California, they can, in fact, be thrown away. However, because they may still contain slight charges that risk being discharged when they're thrown into landfills and such, it's generally recommended that you then store up your used batteries into a cardboard or plastic container that isn't going to conduct, and then throwing that whole item into the trash. Similarly, with things like 9-volt batteries, where the prongs are on the same side, it is recommended that you tape over them. So while this is a arguably tedious process, it is safer in the long run. However, some companies like Home Depot have been starting recycling processes for alkali batteries, and there are also lots of available resources for things like rechargeable batteries from your cell phones, laptops, other electronics. So those can also be brought into Home Depot, as well as often shipped out to specialty companies. All right, now for a few other common misconceptions. It is important, as I mentioned before, to remember to separate different materials, even if you're using single stream recycling. So things like metal lids need to be removed from glass jars, as the magnetic properties of the lid may actually bring not only the lid, but the glass itself over to the metal recycling plant, which again could cause contamination. Things like some bottle caps contain plastic in them. So if you are willing to put in the effort to just pop those out, you can then separately recycle those items. Another common one is the pump mechanism for like soap bottles. Here you have, as you can see on the figure on the right, plastics, a metal spring, and a little glass bead that comprises the overall system. Now, I'm not stating that you should separate out an entire bottle and recycle everything individually. In cases like this, at least remove the bottle, make sure it's reasonably cleaned. You can recycle the plastic. And as for the pump mechanism, that, which is a much smaller piece of material, can simply be thrown away. Another common material that people often will just toss is aluminum foil, which can be found everywhere from a chocolate wrapper or in baking. As long as you can remove crumbs or grease or stuck on foods from the aluminum, you can collect it, crumple it into a larger and larger ball. And as long as it's larger than roughly the size of your fist, it can be brought in with other metals to be recycled. This is actually a really good rule of thumb for all recycling. As long as the material is larger than your fist, it should be able to make it through the recycling process without getting, lost along the way or stuck inside of another material and thus risking contamination. So when it comes to things like metal bottle caps, it's recommended that you, again, store those up in a similar metal container, and then you can just take that whole thing in to be recycled. Another big issue are takeout boxes or pizza boxes, which again, you can only reasonably recycle them if they are clean. As for cardboard boxes, that usually includes the top lid. However, the bottom lid is generally completely coated in grease. It's not something you can get out, and trying to wish cycle that into the rest of your cardboard and papers really just runs the risk of contaminating the overall batch. All right, so in conclusion, first and foremost, you should always strive to reduce. Try and look at your use habits, what you're using and buying, what you're throwing out, what you're managing to recycle. And if possible, try to reduce the amount of those things that you are actually purchasing and using and tossing. You can avoid lots of single-use products like styrofoam cups and those plastic water bottles. And another really common one in a lot of grocery stores is the use of reusable bags instead of their plastic ones. So that's a great way to reduce your habits in creating and throwing away plastics. Another good recommendation is to try and buy products in more recyclable containers. Something that I've been striving to do recently when it comes to buying soda is to specifically go for either like the 12 packs of metal aluminum cans, or in the wonderful natural sugar version of the Mexican Coke bottles. They are in fact made of glass, both of which are materials that are completely recyclable as opposed to plastics. And for those items that you cannot reduce the use of, strive to reuse. Make the use of a product to increase its life before it makes its way into the recycling, or at worst into the landfills. This can be anything from plastic utensils, which can always be reused and washed, to takeout containers, which you can always make use of in mixing paints or something like that. Even rainwater, for example, can be reused with the use of water collection barrels that hook up to your gutters. And then you have a source of clean water for your garden or for washing your car, etc. And finally, if you cannot do either of the previous, recycle. Recycling can be a complicated process, so try to look into what resources are available in your area and what materials can actually be recycled, whether it be through single stream or multi-stream. And if If you're doing it, then make sure to separate your PET ones from your 2 plastics, your clear, your green, your brown glass bottles when possible. For those in the Green Bank area, our group has actually put together a lot of resources for where you can recycle items. And you can find that in the About section in the Life in Green Bank, where we have a link to all of our sustainability resources. So with that, thank you guys very much for listening to me. I see there have been a few comments that I haven't actually been able to read, so I'll get to those in a sec. But at the end of the day, please, if you have resources, share them with your local communities. Keep thinking about ways to reduce, reuse, or if necessary, recycle those products that you use regularly. And the big caveat is with all of this, this isn't a mandate. These aren't things that you must perfect in your lifetime. It's just a process about getting better and trying to think more carefully about the materials that you're using and where they are going to end up. So with that, I thank you guys very much, and I will take any and all questions you have. And unless people want to restate their questions that they've put in the chat, I can read those out and start going over them right now. So the first question is, how much region variation is there in processing availability, machines capable of separating caps from bottles? Right. So unfortunately, this is something that I can't directly answer. It absolutely depends with your local area. Again, the US doesn't have a single organized system. It's very much left to states or counties to deal with their own recycling plants. And those will vary greatly in their complexity, what materials they can handle and how much sorting they can do. So that's something that will actually generally be, you can get an idea of either through looking up online what your area allows, or through the single or multi-stream processes. So usually that's something that your county will provide information for you. Let's see, while they don't recycle it here, glass and Green Bank, they used to do that in Puerto Rico. Right. Yeah, so that's one of the frustrating parts about life here in Green Bank is we do have plastics 1 and 2 recycling, as well as cardboard, but things like glass, where you have to take to other facilities, like a very small and very difficult to find one in up north in Elkins, which is actually great. They separate out, there are different types of glass, but finding it can be a pain. And that's one of the resources on our website. All right. And we have a message from Larry, who has stated the US is not larger than Europe. Fair point. However, individual countries dealing with their products are, and
well, it's a state versus country thing. I appreciate it's a nuanced point. It just your statement was being pedantic. It's fine.
Fair enough. Fair enough. Yeah, it is a very much a nuanced problem. All right. Yeah. So Carla has mentioned the Elkins area where you can recycle glass, and we do have at least in Green Bank resources for things like batteries and electronics. However, this is very much a hit and miss system. My grad school used to have a recycling area for batteries and other electronics, and then miraculously one day it just vanished. So those things are very much unclear. It's all to do with what your local area is willing to handle for you, or in our case, your organization. All right, so I know that it is just after 1 o'clock, but if people do have any other questions they want to unmute themselves for, I'd be happy to talk with you guys for a little bit longer.
Yeah, Jesse, I have a question.
Go ahead.
You look at all into what overhead is involved in some of these recycling processes. I'm particularly curious about, I think it was the second type of high density polyethylene, because something like recycled plastic lumber makes a whole lot of sense. I've seen lots of things use that. It's a beautiful material and it works really well for what it is. And in the meantime, we see lumber shortages all around as far as wood lumber goes. Like, why is this not taking off? Is it just too much overhead to get into that kind of processing?
Yeah, well, so I did mention in my slides, there are actually a few types of plastics that are made into plastic lumber. I believe so. Type 4 and type 5 have been made into plastics. The problem comes with the properties of the plastic. One, that they are able to withstand, weathering, natural environment, and are, a solid enough material that they're going to support a person. So yeah, that's the biggest issue when it comes to how the plastics are recycled, is what can you actually make out of them? But I very much agree that, yeah, that is a great thing to use with a lot of the plastics. Flooring and things like that is another common one, which seems to be very commonly used.
So it sounds like most of the shortage of recycling comes down to the difficulty of sorting, really.
Right, yeah. So the problem is, it's partially with sorting and actually getting materials to the recyclers. But honestly, I think one of the bigger issues, especially with the higher numbered plastics, is just the recycling process is more complicated or more difficult. And so generally, cities will just not bother. That's why 1 and 2 type plastics are pretty much across the board recycled. You'll find places to recycle them, but a lot of the other plastics, places just won't take them. And it's only really recently that things like plastic grocery bags are being collected and recycled. All right, so does anyone have any other questions? If not, we can feel free to contact me. We can talk more about recycling options, particularly in the Green Bank area. And hopefully for those of you in Charlottesville or Socorro, have resources available for recycling as well. So with that, unless there's one final question, I thank you very much for listening to the talk, and I will see you all next week, where we'll have some summer student talks.